Glycogen is the storage form of glucose in all animals. Pretend you just ate a large meal. When our bodies are fed and we don't need any more energy right away, glucose is stored as glycogen in our bodies, primarily in the muscles and the liver. It is also stored in the adipose tissue as fat. The body can be pulling from both the liver and muscle stores at different times for different functions. This polysaccharide is used for different functions. Muscle glycogen is used to provide energy for physical activity, and liver glycogen is used to maintain glucose levels in the blood. When we need more energy due to low glucose levels in the blood, we will start breaking down glycogen to release individual glucose molecules in the blood that we can use for energy. And how is this done? Glycogenolysis. The breakdown of glycogen into individual glucose units in the form of glucose 1-phosphate is called glycogenolysis, and it is catalyzed by the enzyme glycogen phosphorylase. This occurs primarily in the liver in two major steps. Glycogen is highly branched, containing 1,4-glycosidic bonds and alpha-1,6 glycosidic bonds. Glycogen contains a large number of reducing ends from which glucose residues can be cleaved rapidly. Glycogen phosphorylase begins the process when it cleaves alpha-1,4-glycosidic bonds, yielding glucose 1-phosphate. Glycogen phosphorylase is unable to cleave the alpha-1,6 glycosidic bonds and will resume cleaving alpha-1,4 glycosidic bonds after a different enzyme, named the debranching enzyme, cleaves the alpha-1,6 glycosidic bonds. Glucose 1-phosphate is converted into glucose 6-phosphate by the enzyme phosphoglucomutase. Glucose 6-phosphate will be cleaved into glucose in the liver and kidney by glucose 6-phosphatase, which is absent in the muscle. Therefore, free glucose can be formed only from the liver or kidney glycogen and transported through the bloodstream to other tissues for oxidation. To wrap it up, glycogen is important. It is turned into glucose in the liver and muscle through glycogenolysis to give us energy when we need it. It is first turned into glucose 1-phosphate to glucose 6-phosphate, which is then turned to glucose. Glucose can be transported to the muscles through the bloodstream. Without glycogenolysis, we would not be alive.